All right, so we are covering correlation coefficients today, and this is day 1. Learning goals for this lesson. I can determine the type of correlation that a scatter plot has and determine when a scatter plot has a strong correlation. So there are different types of scatter plots. You've got positive, where if you look at them, that kind of has a positive trend. So like it goes up from left to right like a line, we'd say that's positive. Negative, same thing. So if it goes down from left to right, it has a negative trend. If your points are kind of all over the place, that has no correlation. And then nonlinear would be like if we followed this, it kind of has an arc to it, that has a nonlinear correlation. Scatter plot is a graph of a collection of ordered pairs. So all of these points on here, these ordered pairs, it's just a collection. So we're not connecting any dots, we're just plotting the points on the graph. All right. Looks like a bunch of dots, but some graphs are, like I said, kind of in a general shape or move in a general direction, like some of the past examples I just showed you. A positive correlation would be when the x and the y coordinates both increase, like this. So like if you look at this graph, it goes up from left to right. Okay, if we were to kind of draw a line that kind of modeled it. They're both going up and they are both related. A positive correlation example would be if you look at the early years of childhood, the age of a child versus a child's height. As the child gets older, the child gets taller. Okay, so if we were to look at a table, it would be like this. So these points on here, and you can see this one hasn't connected, but those are like the points that are on there. Okay, both of them go up, so it's a positive correlation. Negative correlation would be if the x coordinates are increasing and one is decreasing. Okay, so like from here, if we look at these, it goes down from left to right. All right, one goes up, one goes down. They're related as opposites. Okay, an example of negative correlation is, for example, when you buy a car, the minute you drive it off the lot, it starts to decrease in value, and it continues to do that over the course of the vehicle's life, as we can see by the table below. All right, so age goes up while values go down, negative correlation. No correlation if there's no pattern and the points look kind of scattered all over the place and there's no correlation, such as this. There's no discernible path for the points. Okay, two are not related. Example of no correlation, if you look at the size of the size of shoe that a baseball player wears and their batting average, you will find that shoe size does not make the player better or worse. Okay, so here are some examples. Strong positive correlation. Notice how all of these points are kind of right around what we would call the trend line for this. Weak positive, they still have this kind of like upward trending path, but the points are further out from where this trend line would be. Strong negative, same thing, except it's going down from left to right. And weak negative would be kind of if it's all over the place again, but still kind of going down. And no correlation would be, I can't even figure out what kind of line would represent that. So let's look at the first example. If we look at the scatter plot below, what kind of correlation exists between the variables? Well, if I was to draw a line, okay, they're pretty close around that line. So we would say that it has a strong positive correlation. Looking at this example, what kind of correlation exists? Notice these points are all over the place. So we would say it has no correlation, or in this case, zero correlation. Same thing. All right, third example, we've got kind of points that are all over the place, but you can kind of make out this downward trend. My line's not exactly straight. It's not exactly what it would look like if you tried to put this on your calculator, but you can see these points like are pretty far out from where that line would be. So we would say it has a weak negative correlation. Negative because it's going down from left to right. Weak because the points are spread out from that line. All right, so now to find the correlation coefficient on the Nspire, this is what, we're kind of gonna go through like in the previous videos, except you're gonna do exactly the same thing, except there's one more thing to read. So remember how we found the slope and the y-intercept, but now we're gonna have this box here. This r, not the r squared, but the r is your correlation coefficient, which is important. It basically means how well does the equation that the calculator will come up with truly represent your set of data. It kind of measures the strength and direction of a linear relationship between the two variables. So the positive and the negative refer to the slope, and how close they are to the one kind of show if it's a strong or a weak correlation. And we're going to kind of take this a step further in day 2. Right now we're just going to focus on strong and weak. So even though this is a -1, this would be, in this area is a strong negative correlation. 0 basically means no correlation, and then over here, as we head to the +1, this area in here, strong positive correlation, and then weak would kind of be, in this area here, if your R was, around -0.5 to 0.5, but the closer it gets to 0, the less correlation there is from both sides. So again, correlation coefficient is this R right here, and with this particular example, if we had 0.9937, that's pretty close to +1, so we would say it has a strong. Alright, so like I said, the closer it is to 1 or -1 would mean that you'd have a strong correlation. So let's kind of take a look at what that means in the next problem here. So it asks which of the images below represents the concept of a correlation coefficient that is closest to -1. So that being the case, obviously this first one that we have here, there's no correlation. With this one, you could plug all these values in, and then for grade in class, now this could be all over the place because it's a letter grade. So that could mean, I don't know, if we're thinking about our current grading system, like a 4.0 could be an A, but a 5.0 could be an A, so that's kind of too all over the place. If we look at this one, yeah, this is pretty close, but this is a negative correlation. So this one would be closest to 1, but not +1, -1. If we look at this one here, you go through, and if you wanted to plug this into your calculator, you'd notice that the correlation coefficient was again kind of all over the place, and obviously height and final exam test score have nothing to do with each other, so that one would be no good. So what we're left with is this one right here. Okay, that is the one that would have a closest one. It's going up from left to right. The points are kind of centered around it. That would have a correlation coefficient closest to 1. And that is all I have for you guys for this particular day 1. But correlation coefficient, if you know how to use the calculator and you don't make the mistake of confusing 1 and -1, you should be fine. So that's it, guys. Look for the next one coming up here, and I hope you have a good one. If you have any questions, let me know.